Hello everyone, am I audible? Okay, fine, let's start. Okay, fine. So basically in last class, so I was talking about something called as a NumPy, basically, and parallelly like we have a Python classes going on in your weekdays. So let's try to wrap up this NumPy session, and tomorrow, so I have a plan to start a TensorFlow basically, and after TensorFlow, so I have a plan to start with the PyCharm, which is a purely deep learning based libraries. Now, so in last class, so we have seen that how we'll be able to create an array, and then on top of after creation array, so how we'll be able to do some kind of a manipulation basically with respect to all of those arrays. So we are going to extend a same kind of a lecture, and then we'll see like what and all things can be done over here. So let's try to understand it. So I'm just going to type import numpy as np. Fine. Now, so here I'm trying to use basically one function. So I'm trying to call np numpy, and then I'm trying to call basically a function which is, someone is saying that can't hear. So I think I'm audible to everyone, right? Okay, fine then. Great. So basically in last class, so I was talking about a numpy, and like I said, so I'm going to continue with the same lecture today. So we'll try to close this numpy chapter today. So there is a function called as arange that you will be able to find out. Now, so in Python core, you will be able to find out a function called as range. Now, so basically a range function try to take an integer data set, and then it will be able to generate integer sequences for you. Whereas arange function can take a integer as well as it will be able to take a floating point number, and it will be able to generate a floating point data set as well here in NumPy. So here I have written a very simple statement, as you can see. So numpy.arange I have written over here, and then so let's try to go ahead one by one, I would say. So here, so I'm trying to do something like 10, let's suppose. So if I'm trying to execute this one, so it is going to generate a data set starting from 0 to 9, same as range function. So basically I have given 10 over here inside the range function, and then it is trying to give me a data set in between range of 0 to 9, I can say. Now, so if I'm trying to write like start this range from a 2 to 10. So basically I have given a starting point and I'm trying to give end point. And if I'm going to execute it, so basically it is going to generate a data set starting from 2 and it will go till 9. So excluding upper bound, I can say by default. So the same thing we have observed even in case of a arange function in Python core. Now, so here I can try to give a step size. So I'm looking for a data set, but I'm not looking for a continuous data set. So I'm looking for a 2, after 2, so I'm looking for 4, after 4, 6, and so on. So if I'm going to execute it, so you will be able to find out that I'm able to get this kind of a data. And same thing happens even in case of a range function, I would say. Now, so here in case of a numpy arrange function, I will be able to pass a fraction data set. So if I'm talking about a range function, so you will not be able to find out a floating point number over there. But let's suppose here I'm trying to generate a data set where a step size should be equal to 0.4. Means it should take an interval of 0.4 and then it should generate a data set. So here you are able to find out that 2.0, 2.4, 2.8. So here I'm able to generate a floating point number. So these things are not allowed, I would say, in case of a range function. So if I'm going to generate a data set with the help of range function, it is going to give me an issue. So floating object cannot be interpreted as an integer. So range function always try to take an integer, whereas a range function can try to take a floating point number as well. Suppose if I'm trying to give a floating point range, so floating point upper bound 10.5, that is completely fine. So it will be able to work with me. So if I'm going to execute it, so as you can see, so it is able to generate a data set till 10.4, excluding upper bound, I can say. I will be able to give a starting point, end point, as well as I will be able to give basically a step size as a fraction in case of a arrange function. So these things are valid, I would say, in case of a arrange function, and these things was not valid in case of a range function. Now, so whenever NumPy try to interpret something, so most of the time you will be able to find out that it is going to give you a data set in a form of array or in a form of matrices. In general, it will give you an array. So fine, here you will be able to get an array. In case of a range function, so you will be able to get a range object basically. So you will not be able to get a data set directly unless and until you are not trying to give this data set or like send this data set inside some of the iterators, I can say. So here, fine. So you will be able to get an array. Now, out of this array, if I have to extract a data set, suppose if I'm going to store this data inside a variable called a, let's suppose, and out of that, so if I'm trying to extract a information, so suppose I have a, now from a, if I wanted to extract data set starting from index 3 till index, I can say like a 6, I will be able to get that basically. So this is how I'm trying to give a starting indexes of an array and the end indexes of an array, and then I'm able to extract a data set out of this a, and my a is nothing but it's an array that you are able to see over here. So it's same as, I can say, a list slicing that we have observed, a tuple slicing that we have observed, or a string slicing that we have observed inside our Python core classes. So slicing wise, there is no difference. You will be able to find out. You will be able to slice down a data set. You will be able to print a data set into a reverse order, into ascending order, into descending order, whatever you want, you will be able to do it. So suppose if I wanted to want my data set in a reverse order, so I have given column -1. So whatever understanding you have basically with respect to, I can say, function, previous function, so same thing you will be able to get even in this case. Each and everything you will be able to get it. Now, so this over here, as you will be able to see, so I'm trying to like generate a data set, and then I'm trying to iterate over this data set. So I don't want this data set to be inside the array. So I wanted to extract all the data set one by one, and then I want to print all those data set. That is possible, just like a list. So if I have a list or if I have a range, and out of the range, so I will be able to extract a data set one by one by using this iterator. So fine, same thing will happen even in case of a NumPy. I will be able to extract a data set over here. Now, so here I'm trying to do a same kind of operation. So I'm trying to give like a range, and I'm able to get the data in this place. I'm trying to give a floating point number. I'm able to get the data. I'm trying to get a data into a reverse order. So basically over here, so I'm trying to start from a 50, and then I'm trying to go with -1. So basically it is going to generate data set starting from 50 to -1. So 50 to -1, and again my direction is in a same way. So I'm trying to move into a negative direction. So I have given -5 over here. So I will be able to generate data starting from 50 till 0. So it's same thing that we have discussed. So I think like everyone has attended the class, Python classes at least, and they have an idea about a range function, and based on that, so I'm trying to talk about this arrange function. Now there is another function you will be able to find out, which is called as a line space basically. So what is the meaning of line space? So again, it generates a data for me. So here in case of a line space, so we try to give an upper bound, we try to give an lower bound. So 1 if we have given over here, so it simply means that it's an upper bound, and 5 we have given over here, it simply means that it's a upper bound. So lower and upper bound we have given. Now this is not a step size. So in case of a range function, the third argument was a step size. But here in case of a line space basically, so this is basically the number of the data set which I'm looking for in between 1 to 5. So whenever I'm going to execute it, so you will be able to find out that it is going to give me 100 data set starting from 1 till 5. So starting from upper bound, so like starting from a lower bound till upper bound, so it is going to give me 100 data set. If I'm looking for a 10 data set, so you will be able to get 10 data set. So even in this case, as you can see, so here it is trying to give me a 10 data set in between 1 to 5, and all the data set, all the adjacent data set, I would say, is equally distant basically. So it is trying to take a step size, and step size is nothing but it's equal to, I can say, 1 to 5. So basically the distance is 5 divided by 10. So that will be a step size but it is trying to take, and based on that, so it is trying to generate a data for me. So this is how you will be able to use basically a line space. You will be able to use this line space basically, and then you will be able to work on that. So line space is again another function which try to produce a data for you. Arrange is another function which try to produce a data for you, and you will be able to get that. Now in NumPy, so you will be able to find out that there is something called as zeros. So suppose if I'm looking for all the zeros, because whenever you will try to create a neural network, so at that point of a time you are going to use this zeros function, this ones function, to create a biases, I can say. So here, this numpy is going to help you out. So numpy dot zeros, if I'm going to call, and inside that, so I have passed basically 5. So it means simply means that it is going to create basically a 5 zeros. So array of 5 zeros it is going to produce, and as you can see, so it has created basically an array which is having 5 zeros. Now here I'm trying to call numpy dot zeros, and 3 cross 4 I have given. So in this case, it is going to create an array of dimension 3 cross 4, 3 row, 4 column. And then, so all the data set inside this 3 row and 4 column will be 0. So there won't be any other data set except zeros. So this is what zeros as a function does. Now you will be able to find out a similar kind of function called as ones. So again, whatever we have discussed in terms of zeros, so same thing has been done by ones. So if I'm going to execute it, so it is going to create an array, and the number of element inside this array will be equal to 5, I can say. Now here, if I'm trying to call np.ones 5 cross 2, so in that case it is going to generate an array of dimension 5 rows and 2 columns, and all the element inside this array will be equal to 1. So this is what happens in case of a zeros. This is what happens in case of a ones. There is no such function called as 2s, 3s or 4s. So don't even like think about that. Basically there are only 2 functions which generate 0 and 1, which is available as a numpy.ones and numpy.zeros. That's it. This is the only function that you will be able to get inside numpy. So fine, here I'm trying to generate basically a 3 cross 5 matrices. So 3 rows, 5 columns, I can say. And here, so I'm trying to multiply each and everything with 5. So here it is going to do element wise multiplication. So with respect to each and every element, so it is going to multiply. And then this is the matrices that you will be able to get. Now, so there is a function called as numpy.empty. So empty doesn't mean that you will be able to get an empty matrices. No. So basically it is going to give you a matrices with the random values. So close to 0 or maybe some random values you will be able to generate over here. So I'm trying to call numpy.empty, and here I have given a dimension of 3 cross 5. Again, if you wanted to increase the dimension, you can increase that as well. So 3 cross 5 cross 2 doesn't matter. It's completely fine. So basically it has created 3 matrices. It has created basically 3 matrices of dimension 5 cross 2. Means we have a 5 cross 2, we have 5 cross 2, and we have 5 cross 2. So one after another, or I can say like a one behind another. So I have basically 3 matrices, and this is how this representation looks like. I would say it's just like a book. So if you try to open up a book, if you try to show your pages one by one, so basically if you have one pages, then another pages, then another pages. So in the similar way, you can understand that we have 3 matrices. So of size 5 cross 2, 5 cross 2, 5 cross 2, one after another. So you can say that we have a x-axis, y-axis. So let's suppose x-axis is 5, y-axis is 2, then z-axis is equal to 3. So basically in a z-axis, we have a dimension is equal to 3. So we have a 3 matrices in a z-axis. That's it, I can say. So here you will be able to generate any dimension of the matrices. So 1D, 2D, 3D, I can say, or 10D or ND matrices that you will be able to generate. There won't be any restriction. You just have to mention the dimension over here, and then it will keep on creating all those matrices for you. But again, if you are going to increase the number of dimension, so readability will decrease. So you will not be able to understand that how this arrangement looks like actually. So this is like this is what you will be able to get if you are going to increase the dimension. But yes, it is possible to create a matrices or create an array inside a numpy with any dimension. There is no restriction. You will be able to find out with respect to a dimension in case of a numpy. Fine. So here again there is a function called as I. So we might have heard about the identity matrix in our childhood. So when we used to study mathematics, algebra basically in our childhood, so we talk about always a kind of a matrix which is called as a identity matrices. So property of identity matrix says that determinant of identity matrix will be equal to 1. Means if you will try to multiply, if you will try to find out the solution, or like if you try to solve that matrix, you will get a value 1. That is one thing. Second thing is, all the diagonal element of that particular matrices will be 1 basically, and that matrix should always be a square matrices. That is a meaning of identity matrix, I can say, in mathematics, in algebra. So here you will be able to create an identity matrix by calling a function called as EYE. So here I'm trying to call this EYE over here, and as we said, as we have discussed, that the dimension of identity matrix will always be a square matrices. So number of rows and number of columns will always be equal. So we have given 4 over here, and in this case it is going to create a 4 cross 4 matrices. 4 rows, 4 columns, and all the diagonal element of that matrices will be equal to 1 in that case. And if you try to find out the determinant of this matrices, so determinant of this matrices will always be equal to 1. So this is the property of the entry matrices, and you will be able to create it basically. So here I'm trying to create a matrix 1, and which is having a dimension 4 cross 4, so that is completely fine, I would say. And here I'm trying to find out the matrix 1 dot shape. So matrix 1 dot shape is nothing but a dimension. So shape always had to return a dimension of the matrices. So here I'm able to get 4 cross 4, and yes, this is the matrices. This is how it looks like basically. So all the diagonal element is equal to 1, you will be able to find out. So that is completely fine. Now here, so I was like talking about a line space basically. So again, here I'm just trying to show you a same kind of a thing. So I have to discuss few more points with respect to a line space, I would say. So here I'm trying to call numpy dot line space. I have given these two number, and meaning of line space as we have already discussed. So in case of a line space, it try to generate that many numbers in between that range. So I have given 2 and 3. So I have given lower bound, I have given upper bound basically, and I'm trying to say that okay fine, give me 5 data set in between 2 to 3. So it is going to give you 5 data set in between 2 to 3. Now if you try to observe on an outcome, so it is trying to include basically your end point, or I can say it is trying to include your upper bound as well. In case of a range function, in case of a range function, it never includes upper bound, but in case of a line space, by default it is trying to include your upper bound. Now, so there is a parameter you will be able to find out, and you can control it basically. There is a parameter called as endpoint. So by default, this endpoint will be equal to true, and that's the reason. So you are able to get your upper bound as well. Now, if you're going to make this endpoint is equal to false, so in that case, it is not going to give you an upper bound. So upper bound will be equal to false, and if I'm going to execute it, so I have given upper bound is equal to 3, so it is not considering 3 at all. So it is trying to generate a data set in between an upper bound and lower bound, 5 data set basically, I can say, like without considering an upper bound. So like a 5, I can generate 500 data set as well. So whatever I'm looking for, so I will be able to generate like a 500 data set or 5,000 or 5 lakh data set at any point of a time. So these things are possible, I can say, in case of a numpy. So fine. Again, if you are going to set this parameter, ret step is equal to true. So in that case, you will be able to find out that it is going to tell you that what was the step size. So when it has generated this data, so what was the step size that it has taken? So you will be able to get that step size is equal to true. So like in that case, like it has taken a step of 0.25 to generate every next data set. So as you can see, 2 plus 2.5 is equal to 2.25 plus 2.5 is equal to 2.5 plus 2.5 is equal to 2.75. So this is what happens in case of a line space. So we have seen a range function, we have seen a range function, we have seen a line space. Now the next thing that I'm going to talk about is a log space basically. So log space is similar to a line space. The only difference is it is going to give you a data on a logarithmic scale. So whatever data it is going to produce, so it will try to find out the log of that, and then it will be able to give you. So suppose if you are generating a data set which is having a logarithmic in tendency, so you will be able to generate even those data sets. So I'm trying to say numpy.log space, starting range, like a start point, end point I have given, and the number of data which I'm looking for. So I have given basically that I'm looking for a 40 data set in between 2 to 3. And here, so it will try to find out a logarithmic of everything, and then it is going to give it to you. So here I'm trying to make endpoint is equal to false. It simply means that basically that, okay, so it will not consider a final point. It will try to like reject this final point and accept final point. So it is going to take all the data set and it is going to produce and generate a data set, I can say. Now here I'm using log space. You will be able to find out logarithmic with any base. So we all know that we used to create a log value, or we used to find out the logarithmic value based on a different base, in general base 2 and base 10, which is a popular one, I can say. So if I'm looking for a logarithmic data set on certain base, so even I will be able to do that. So here you are just supposed to set a base is equal to a values on which base data you are looking for, and you will be able to generate even those data set with any number of base. So previously we have generated data set based on base 10. So now I'm generating a data set based on base 2. So yes, that is working completely fine for me, and I'm able to get the data. Now here, what I'm trying to do is, so I'm trying to call numpy.arange. So as we know that if I'm going to give numpy.arange is equal to 9, so in that case, it is going to generate a data starting from 0 to 8. Means it is going to generate basically 9 integer for me. That is for sure, I would say. Now, so what I wanted to do is, so I'm not looking for 1D matrices. This is basically 1D matrices that we have generated. So basically I'm looking for a 2D matrices, or maybe I am looking for a 3D matrices out of this one. So I will be able to reshape this matrices at any point of a time. This reshape function is important. You are going to use this reshape function frequently, I can say. So here I'm trying to generate a 9 data sets, I can say. Now, so if I have 9 data sets, I can reshape this data set into 1 cross 9, 9 cross 1, 3 cross 3, I would say. So in these ratios, I will be able to produce a data set. So let's try to do that. So what I'm trying to do in this place is, so I'm trying to call a reshape function. And what reshape function will do over here? So reshape function will try to reshape my data set in between certain shapes. So suppose if I have given 1 cross 9 over here, so 1 cross 9, if I'm going to do that, so in that case, as you can see, so this is the 2D matrices which it has created. It is having a 2 bracket. So number of row is equal to 1 and number of column is equal to 9. If I'm going to change this, 9 cross 1. So basically number of row is equal to 9, number of column is equal to 1. I can reshape these things into 3 cross 3 basically. So number of row is equal to 3, number of column is equal to 3. So I'm able to transform, I'm able to reshape my data set one by one in this place. Now what I can do is, so suppose I have written 3. Now I can write minus 1 over here. So suppose I have written 3 and the next dimension which I should give, so number of rows I have given over here and number of column which I am supposed to give is equal to 3, because then only it will be equal to 9 data that we have inside my row or inside my arrays, I can say. So basically if you are going to give minus 1 over here, so by default it will be able to understand that what will be the column size. So if I'm going to execute it, you will be able to get the same output. If I'm going to place minus 1 over here, and if I'm going to give 3 over here, so minus 1 or negative number simply means that it will be able to find out the other dimension. So if you have given one dimension, it will be able to find out other dimension by default. So now generally whenever we use write a code, so we frequently use this minus 1, but there is no hard and fast rule that you should only use minus 1. You can use any number over here, any negative number you are supposed to use. So you will not be able to find these things, I would say, anywhere. Like people generally use minus 1. Sometimes it's confusing. People think that, okay, it's a kind of a rule, but no, it's not a rule, I would say. You can use any minus number, any negative number as a row, any negative number as a column. So it will be able to understand the alternate dimensions. So as I have just given some random minus number, random negative number over here, still it is able to understand that number of row is equal to 3, I would say. Now, so here, suppose if I have given 4, in this case, what will happen is, so it is going to give me error basically, because it will not be able to correlate. I just have a 9 element. I can only reshape 9 element and it will always look for a factor of 9. So whenever you're trying to give a rows and a column, so make sure that it is always a factor of 9, then only it is going to work. And then number of column and number of rows should always be, so multiplication of number of rows and columns should always be equal to the number of the data that you have generated. So this is what you are supposed to follow at any point of a time while reshaping a data set. Otherwise, you are going to get an issue. Otherwise, it is going to give you an error, I would say. Now, not only into a 2 dimension. So if I wanted to change the dimension, if I wanted to like generate a data set with a multiple dimension, I can do that as well. Suppose if I'm looking for 3 cross 3, or maybe I'm looking for 1 cross 3 cross 3. That is possible. I can do that basically. So now I have created 3D data set. Basically, you will be able to see a 3 rows over here in this particular place. I can say maybe 3 cross 3, 3 cross 1 cross 3. That is also possible. So basically, I have 3 array of size 1 cross 3, 1 cross 3, 1 cross 3. This is what you will be. This is how you will be able to understand each and everything. Reshaping of the array. So you will be able to reshape our array in case of anything. So I can write another one kind of a things, and you will be able to get this kind of a data. So reshaping of array is possible in with respect to any of the shapes, and yeah, depends upon the requirement. So you will be able to convert your array in any kind of a shapes, and this is like one of the useful function that you will be using very frequently, I can say. So anyone who is having any concern, and doubts, any questions with respect to these points, go for the question. We'll take some question, then we'll move ahead.
Yeah, Sudhanshu. So basically, as we discussed previously, -1 denotes the number of element present in an array. Okay.
Minus 1 basically try to minus 1, not only minus 1 I'm saying that any negative number. So
Correct.
suppose if I have given 3, right? So 3 is one dimension. So
Correct.
the rest of the dimension could be 3.
Any minus number we can give.
Right? Any
Yeah.
minus number I can give. See, I have executed it. Right?
Correct.
So generally you will be able to find out that people used to denote these things by minus 1. But no, minus 1 is not a rule. Nowhere it's been written that okay, you are just supposed to use minus 1. So you can use any negative number, it will work in the similar way.
Okay, any negative number donates the number of element present in an array.
No. So basically, I have 9 elements inside my array. Agree?
Correct.
I have given a row size is equal to 3. Agree? So what is the remaining dimension? Can I say it will be 3?
3, correct. Yeah.
Remaining dimension is equal to 3. So if you are giving negative number over here, so automatically it will understand that okay, so this could be equal to 3. So internally it will try to replace this negative number by 3.
Okay.
This
no,
is what
previously actually what Krish was taking the previous class in machine learning batch, he was telling that the negative number donates the number of element present in an array. If we are giving any negative number, that donates the element present in an array. So we are giving, yeah, that's why I'm asking this question.
No, that doesn't happen. Like I think there is certain confusion. He was trying to explain certain things in his way. That is one thing, right? So let me show you one live example. Okay. So suppose if I'm giving minus 1 over here, right? And if I'm going to leave it, right?
Correct.
Now, see, I have given minus 1 in this place, right?
It's a single dimension array with
single dimension array. So
number of element.
Yeah, so it is automatically able to identify that I'm trying to reshape this element, right? With respect to 9 data set. Now, instead of using minus 1, I can use any number. See, it's working fine for me, right? So that's the reason I'm telling you. So minus 1 is not a hard and fast rule that you should use. First thing. Second thing, I would say. So suppose if I'm trying to convert this data into multi-dimension, right? So if I'm going to use minus 1, basically, and minus 1, it will give me error. Basically, because you are trying to create 2 dimensions and you have not given either of these dimensions.
Okay.
Right? So it will not be able to understand that, okay, so what will be the row size, what will be the column size?
Correct.
So basically, whenever you're trying to use this minus 1, so you should either give row or either give a column, I can say, and it will be able to find out the other one. So it will be able to find out the other one, and negative wise, you can give anyone. Minus 1 is no hard and fast rule. Nowhere has it's written that you should only use minus 1.
Okay, whenever we are using minus thing, then we should define in any of this row or column. Then only.
No, it's not like that. In one dimension, you are not supposed to do that.
Correct. One dimension, it only shows the number of elements. Correct.
Yeah. So in multi-dimension, I'm talking about. In multi-dimension, I can say. So you are supposed to give the alternative one, and then rest of the things it will be able to decide by itself.
Okay.
Yeah.
Okay, got it. Yeah. Thank you.
Sudhanshu, can you explain about this log space?
Which one?
Log space.
Okay, log space is okay. So have you got an idea about line space?
Yes.
Okay. So what line space does? So line space try to generate data, right? So here I have written that okay. So give me 5 data set in between 2 to 3. Agree? So it has given me these data sets, right? So when you are going to call basically a log space, so it is going to find out a logarithmic of all the data set, and then it is going to give it to you.
Okay.
Making sense?
Okay.
Yeah.
Yeah, Sudhanshu.
So people who are not asking questions, right? So please try to be on mute patiently. Otherwise, I'll have to remove. There is no option.
Yeah.
What about the sender space? Endpoint here.
So endpoint means that suppose if I have not given endpoint, right? So what is my initial point? 2. What is my final point? 3. Right? So in my result, can I say that it is including my final point as well?
Yes.
Yeah.
In line
if I'm
space
trying to make, yeah, so it will not include that one. That's the meaning of it. Yeah. Okay.
Sudhanshu Rajgir.
Go ahead.
Sudhanshu, line space mean
Line
numbers
space.
are divided. Yeah,
Line
space mean numbers are getting divided in a linear.
Number is getting divided into equal steps, I can say. So suppose if I'll tell you that okay, fine, give me 10 number in between 1 to 10, and basically all those 10 numbers should be equally divided. what you will do? You will give me 1, 2, 3, 4, 5, 6.
Right.
Right? And difference between each and every number is equal to 1.
Correct.
Right? Means the step size is equal to 1. Right?
True.
Same thing it used to do over here. So it is going to give you produce a number between 2 to 3, and then steps will be equal. If you try to check your data set, the steps is equal basically. So 5 data set it has given to you. On every data set is having same steps. Difference you will, if you will try to find out between these two or between these two. So any adjacent one, you will be able to find the same space in between. Fine.
Okay.
This is what line space does.
Sudhanshu, I have pinged you in the chat box. Could you please respond to
Can
it?
you please hover a little down?
Okay. So what is okay? Many people have actually pinged me. Can you please tell me your name?
Sri.
NumPy class on ML weekdays batches is a new topics being covered today. Additional weekdays. No, still. So like yesterday, in last Saturday, I think we have started this topic. So whatever we have started like whatever topics we have started in last weekend, so we are trying to wrap up that topic itself. This
But
topic
we have already discussed the neural network, right? In between.
No, on Saturday we have discussed neural network. On Sunday we talked about basically NumPy, and I'm going to continue with the same lecture. So whatever I used to discuss, whatever I used to talk about in a weekdays, I continue with the weekdays itself. Whatever I discuss in a weekend, I continue with the weekend. I don't try to bring like a weekdays into weekend and weekend into weekdays. So
But
Saturday
we have done with neural network, right?
Yes,
and,
yeah, and basically like on Sunday, have you attended a Sunday's class?
No, I
have
did
you
not.
seen the recording? Have you
But
gone through the recording?
No, I do have only February 1st recording there.
No, it's already available in NumPy section. So many people have pinged me, and then this section in this NumPy section, so these recordings are available. So in last Sunday, so we have taken basically a NumPy classes because NumPy is important to understand neural network, to understand TensorFlow basically. And this is what I said. And then like we have already taken this class on 2nd February. So I think on 1st February we have discussed TensorFlow. On 2nd February, on 1st February it was a neural network. 2nd February it was NumPy.
Okay, so we are going to continue this lecture only for the weekends also, right?
Yeah, like I said, so whatever I start in the weekend, I go ahead with the weekend itself. Yes? Okay.
So the Sudhanshu coming back.
Yeah, go ahead with the question.
It's Ashwant here.
Yeah.
In multidimensional, if you go to reshape.
Okay, reshape.
Yeah, in multidimensional, if this is a 2-dimensional. And in 3-dimensional or 4-dimensional, like how it will arrange actually, like see here, if you give 2-dimensional 3 into 3,
so basically what will happen in this case is, so it is going to create a 3 array.
3 arrays, correct.
Right? 3 array of size 1 cross 3. So every array is having what size? 1 cross 3, can I say that? 1 row, 3 column?
Yes,
this is how it's going to arrange.
Okay, if you give one more,
so in that case, you will not be able to understand a dimension. Till 3 dimension, you will be able to understand it.
Yeah.
But beyond that, so you will not be able to visualize it basically. Right? So this is what I have mentioned. So if you try to increase the dimensions, so readability will decrease in that case.
Okay.
Yeah.
Okay, fine. Yeah. Thank you.
Sudhanshu,
there
but what
isn't
is
the
happening in this? I know we can't visualize it, but can you just give some intuition on what is happening when you add one more number?
So basically, when I add one more number over here, right? So what is the size which I have given? So basically, I have given 3 cross 1 cross 3 cross 1, basically, right? So in this case, what will happen is, so it will first of all divide the outer matrices into 3, I can say. Now inside that, so I will be having 1 1 matrices, and then out of that, so every matrices is been divided into 3 cross 1, 3 cross 1, 3 cross 1.
Oh, okay.
So 3 rows, as you can see, 3 rows, right? And 1 column, 3 row, 1 column, 3 row, 1 column. This is how you can understand that.
Okay, thanks.
Hello, sir. Hello.
Sudhanshu,
Hello, sir.
Sudhanshu, you mentioned, we mentioned, I mean,
Sudhanshu, can you explain the empty concept?
Which concept?
Empty.
Empty is basically going to generate basically a random data set. So empty doesn't mean that it is going to give you like an empty matrices. It is just going to generate some random matrices, and then if you try to check the power, right? So power will be like a 2 less. So e to the power 175 or something like that. E to the power some 100 or something like that. It is going to give you, or negative of this. It is going to give you. So it's just generate a random data set. Empty doesn't. People generally think that okay, empty is going to give me some empty data, empty matrices. That never happens. So there is nothing called as an empty matrices. It is going to give you just a random data set with random values. That's it.
Okay, so here like it is a 3-dimensional matrix, is it? 3.
Yeah, basically I have created 3 cross 5 cross 2. So yes, it's a 3 dimension. So like we have a 3 matrices of size 5 cross 2. So every matrix is having 5 row, 2 column, 5 row, 2 column. You will be able to find out, right?
So the dimensions comes into the first parameter.
No, it's not like that. So you should visualize these things with respect to axis actually. So okay, I'll just check my
Because
diary,
yeah,
and
I
then
have
I'll
it.
try to explain you.
Because like if you provide 2 parameters, it takes us like rows and columns, right? So but when
See, what happens is this is a 3D object, right? 3D object, right? So basically what happens is, suppose this is one array. Suppose this is 5 cross 2 matrix, this one, right? So this is 5 cross 2 matrices. And then again, if I'll try to take one page, again 5 cross 2, another 5 cross 2, then again another 5 cross 2. So basically one after another, you will be able to visualize. So in this way, you should visualize. I have basically 3 pages, which I have taken over here, right? So 3 into a Z axis. So you can say that, okay, fine. So this is the Z axis that we have. And then this is X and this is Y axis. So basically your X axis is 5, Y axis is equal to 2, and then Z axis is equal to 3. Just like a page of books, you can visualize in 3D. 4D, you can't visualize.
Hello, sir. I'm a student of ML deployment batch also.
Yeah.
Actually, I have attended all the classes of this NumPy in ML deployment batch.
Okay, so that's great. Yeah.
Should I? So is the actually in dashboard I see some additional topics like linear algebra with NumPy and basic stats with NumPy, etc. and uploaded in the deep learning dashboard. So will all those topics be covered today?
Almost, I can say almost, because tomorrow we are going to start with the, I guess, TensorFlow.
Yeah, okay, sir. Thank you.
Yeah. Fine. So moving ahead with the new topics, I can say. So we have discussed till this point. Reshape is done. Okay. Now, so let's try to understand these things. Diagonal vectors. It will give you all sorts of pain for sure. So yeah. So this is the matrix that we have, as you can see, like a 3 cross 3. And if we are going to give like a diag. So suppose if I have given np.diag of x. So basically diagonal is diagonal. So it is going to give me a diagonal element of these matrices. So it is going to give me basically this one, as you can see. So it is going to give me diagonal element 048. So fine, I am able to get 048 in this particular case. Now, so here in this diag, so you will be able to find a parameter. So you will be able to find a parameter called as k. So for k is equal to 0, so it is going to give you 048. Now I can visualize in this way. I can try to understand these things in this way, basically. So this is the array and 0, 1, 2. 0, 1, 2. So 0, 1, 2, row index, 0, 1, 2, column index, as simple as that. So if I'm trying to visualize here, k is equal to 0, which is the default parameter, k is equal to 0, it simply means that, so it will start from 0 and will try to give you this diagonal element at any point of a time. Now, if I'm going to change this k value, so if I'm going to make k is equal to, I can say, let's suppose k is equal to 1. If I'm going to mention. Now, in this case, what will happen? So whenever I used to mention k is equal to 1, so it is going to give me 1 and 5. So let's try to visualize it. 0, 1, 2. 0, 1, 2. Now, so when k is equal to 1, so in that case, it is going to start from 1. It will try to take a square matrices starting from 1. And then whatever diagonal element you have, it is just going to give a diagonal element of that particular matrices, I would say. So here, k is equal to 1. Yes, this is the diagonal element that I'm able to get. And it is able to give me 1 and 5 in case of k is equal to 1. Now, if I'm going to give k is equal to 2, so what will happen in k is equal to 2? So if I'm going to give k is equal to 2, so in that case, basically it is going to consider data from second indexes, and then it is going to give me all the data sets. So suppose if I'm going to give k is equal to 2, so 0, 1, 2, 0, 1, 2. So 0, 1, it will not take on 2. We have this one, and this is the square matrices. Now diagonal of this element is element itself, I can say, and that's the reason. So we are able to get 2 over here. So this is what happens in case of a diag, I can say. So whenever you are going to give a positive value of a diag, so this is what it is going to do. Now let's try to visualize these things with a bigger size of a matrices. So maybe I can try to generate like I can say 25 data set dot reshape if I'm going to call on top of this one. So let's see what happens. So reshape is into 5 cross 5. I can say, let's try to put one. Fine. So this is the matrix that I have. Now if I'm going to give k is equal to 2, so what will happen? So whenever I'm going to give k is equal to 2 in this place, so basically I have this matrix and 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Now, so it will start from here. So it will try to take this square matrices, I can say. And now for this square matrices, this is the diagonal element, 2, 8, and 4. So it is going to be done 2, 8, 4 in this case. This is how it happens, how it is going to give you a data set in k is equal to positive values. Now let's suppose k is equal to -1. What will happen in -1 case? So if I'm talking about -1 case over here, so in this case, so let me show you. So -1 always starts from the negative side. So -1, -2, -3, -4, -5, I can say. So it's fine. -1, -2, -3, and so on. This is how it is going to start. So -1, let's try to consider this axis. So it is going to avoid this data, this data. It is going to pick this square matrices, and then for this square matrices, this is the diagonal. So it is going to give me 5, 11, 17, 23. 5, 11, 17, 23. So this is the data that you will be able to observe in case of k is equal to -1. If I'm talking about k is equal to -2, basically, so in that case, what will happen? Similar thing I can say. So it will try to avoid this -1, -2. So whatever is a remaining matrices that I have, so it is going to give me a diagonal of that. So it is able to give me a diagonal of that over here, 10, 16, and 22. So you can just play around with this diagonal. So whatever diagonal you are looking for of the subset of matrices, you will be able to extract those diagonals. There won't be any issue. You will be able to get the final values. So this is what I was trying to talk about in this subsequent section, I can say. Now, if I'm trying to find out a diagonal of x, so diagonal of x is nothing but, so it is going to give me basically like a 0, 6, 12, 18, and 14, 24, because this is my x value that I have. This is my x data that I have. Now diagonal of this one. Now if I'm going to call diagonal of this one, so in that case it will be able to reconstruct my entire matrices. So as you can see, so I'm trying to call diagonal of x, so it is going to give me all the diagonal element. That is fine. Now if I'm going to call diagonal of this x, so in that case in general this should not happen, but yeah, this is how whenever you're going to call like a diagonal on, I can say, a linear element or 1D element, so it is going to deform the matrices. So here in this matrices, you will be able to find out the diagonal element is nothing but this element which I have extracted, and rest of the element is equal to 0. So this is what happens in case of a diagonal of matrices, basically. So yeah, sometimes it's useful, and these are not a function which you are going to use on a day-to-day basis. These are some of the pretty advanced function, I would say. So whenever you will try to create your own like algorithm, your own neural network kind of a things, your own mathematics, your own formula. So in that case, generally we use all of those things. Apart from that, so as per the regular users is concerned, so you're not going to use on a daily basis. It's very rare that you are going to use these things especially. So like a reshape or array as any array. So these are something which we use very frequently, but not this one. So fine, I'm having this another like a method which is a diag flat. So what diag flat does? So basically I have list inside a list, as you can see over here. So I have like two lists inside one list. So I have a bigger list. Inside that I have two lists. One list is having 1 and 2. Another list is having 3 and 4. So fine, what diagonal flat will do is, so it will try to flatten. It will try to flatten the entire data set. Flattening means what? So flattening means it will try to form a single list. So it will try to take these two lists. It is going to give you a final list with 1, 2, 3, 4, basically. And then, so it is going to convert everything into this matrices, as simple as that. So it is going to convert everything into this kind of a matrices. This is what you will be able to receive. So this is what happens in case of a diagonal flat, I can say. Now diagonal flat 2. Now what is the meaning of diagonal flat 2? So diagonal flat meaning of diagonal flat 2 is nothing but same thing that we have discussed, k values basically. So if I'm calling this diagonal flat 2, so in that case what will happen is, so it will try to reserve this 2 space. So as you can see, 2 spaces is reserved. So horizontally as well as in this one. So horizontal and vertical way. So it is going to reserve these two spaces, and then in the rest of the space, it is going to accommodate 1, 2, 3 as a diagonal element. So here value of k is equal to 2 that we have taken, and because of that, it has reserved this one. If I'm going to say 1, then in that case, it will try to reserve basically a first row and last, first column, last row, and then in rest of the area, so it is going to give you a data set. So in the simplest possible way, this is what is going to happen. Now here I'm trying to talk about trie. So trie is basically like it's a kind of trigonal matrices. It is going to generate, I can say. So trie takes basically these three parameters. I would say n. So n is nothing but a number of rows. M is nothing but I can say a number of column, which is the optional one, and k is nothing but I can say diagonal. So subdiagonal I can say. So subdiagonal parameter is equal to k. So here let's try to understand this. It's a bit difficult, I would say, and most of the people will not be able to understand for sure. So here I have given 3 cross 5. So 3 cross 5, whenever I have given over here, so it is going to generate a data with 3 rows and 5 columns. So that is completely fine. It has generated data with the 3 rows and 5 columns. I'm able to get that. Now, let's try to understand in this way, 5 cross 5, so that with the square matrices. Okay, here. So basically, I'm trying to generate a trigonal matrix over here. So 5 cross 5 is the dimension which I have given. So it is going to create a 5 cross 5. So find whatever matrices it has created. So everything is 1, and by default, data will be equal to 1 and 5 cross 5. But here you will be able to find out that 0, 1, 2. So below this one, so all the data is 1. Above this one, all the data is equal to 0. So this is called as a triangle, basically. So try to create a triangle, I can say a lower triangle. In lower triangle, all the data will be equal to 1. In upper triangle, all the data should be equal to 0. So basically after 2, if I'm going to make these things as a 3, so in that case, situation will change, I can say. So if I'm going to say like this is equal to 3, so you will be able to find out that's still 3. So basically this is the lower triangle which it has created in case of a 3. So this is the lower triangle, all the data set is equal to 1, and then for upper triangle, so data set is equal to 0. If I'm going to keep these things as equal to 1, so if I'm going to say 1, in that case what will happen? So in that case same thing will happen, I can say. So 0 and 1, so whatever data we have below this diagonal, it's 1. Above that triangle, so I can see it's a 0. So this is what happens in case of a trigonal matrices. Now you can try to play around with negative values as well. So if negative dimension as well. So if you're saying -1 over here, so if I say -1 in this place, so what will happen in this case is, so -1, it will leave, and then whatever data you have, so like it is going to give you -1, so -1 will leave, and then rest of the element will be equal to 1, above element is equal to 0. This is what happens in case of a negative axis. So this is just a procedure, this is just a way to create an upper diagonal matrix, upper triangular matrices, lower triangular matrices. And like I said, so this is not a commonly used function. You will not, I don't think that in 99.99% of the cases you are going to use it. Maybe out of 2,000, 3,000 people, maybe one person will be using these things in their research, I can say. It's not a regular function that we generally use, I can say. Now, so here I'm trying to say like a tri-L. So basically it's a triangle lower, I can say. So triangular lower matrices, which I'm trying to create in this place. So here I'm trying to provide a list, this. So here is a list which I have provided in this place. I've given -2. So from -2, it is going to form a lower triangle. So in lower triangle, it will keep the data. In upper triangle, it will try to nullify all the data sets. So it will try to give you just a 0 in the upper triangle, and in lower triangle, so you'll be having some integer. This is what happens, I can say, in case of a lower triangular. In similar way, so you will be able to create the upper triangular. So in upper triangular, basically, like all the data set above that particular triangle will be like a original data set, and below that, so it is going to convert every data set, I can say, into a zeros. So this is what happens in case of an upper triangle. This is happens in case of a lower triangle, I would say. So before moving to the next one, so anyone who is having any concerns, so go for that. We can take 2-3 questions now.
So please, can you share this file for us, because this is not.
It's already uploaded, but it's uploaded in a bits and pieces actually. So I have just broken down all those files into a small files, and this file is available in your dashboard.
Okay. Fine.
Hello, Sudhanshu.
Yeah.
Hello, Sudhanshu.
Yeah.
Can you hear me?
Yeah.
Coming to here, diag and diag flat. I have a small doubt. In case of positive numbers, I will go to the column wise. In case of negative numbers, I will go to the row wise.
No. even in case of a negative number, you're going to the column wise,
Yeah,
but
even just
from
now,
a reverse direction.
Yeah, just now I cross-verified. If it
Yeah.
is a negative number, if I go to the row wise, it is giving the exact value.
Okay, example?
Yeah, it exactly. You can check it.
No, which one? So just tell me, like which. So suppose I have this. Let's
Yeah,
suppose
put
I
the-
have this matrices, right?
Yeah,
Now tell
yeah.
me. So what is the k value which I should give?
Yeah, -2. Put it a -2.
K is equal to -2 I have given, right?
Yeah. For a second, just mention the columns as 0, 1, 2, 3, 4, and row as 0, 1, 2, 3, 4. Okay.
Sorry, what was that?
Yeah, columns give a numbering just like 0, 1, 2, 3, 4. Yeah, and row also 0, 1, 2, 3, 4. Okay.
Okay.
Now it is a -2, right? I will go from the
-2 I have given, basically.
Yeah. If I go from the row, start with the row 2.
Okay, 2, fine.
Yeah. Yeah. Take a 3 by 3 matrix.
So check a 3 by 3 matrix of this one, right?
Yeah. Is it giving the correct number?
See, this could be correct, but interpretation wise, it's not correct at all. Whenever we say -2, right? So actually it starts from here.
Yeah, we should eliminate.
Negative axis doesn't even exist in a positive direction, right?
Yeah.
So basically the interpretation is wrong. You can try to explain yourself in this way that, okay, so from 2 it is trying to create like a 2 cross 2 matrices, right? But I can't try to explain in a similar way.
Just for understanding.
Right?
Thank you.
Because just for understanding, just for your understanding, you can say that okay, fine, from 2 cross 2 it is trying to take a. Right, but when I say minus means I have to take a minus axis. To minus axis, I should explain you, right? And this is what I was trying to do. So that explanation is not correct, but yeah, for your understanding, I think it's fine. If you're able to understand in that way.
Yeah, thank you.
Yeah. So like, yeah. Any other questions we have?
Yeah, can you please explain NP dot try L and try U once? I'm sorry, I'm not able to get it exactly.
So try L basically try to give you a lower triangular. So suppose if I'm not giving this -2, right? Let's suppose. So basically what will happen is, so like this is going to give you these things because by default value of k will be equal to 0. You will be able to find out over here. Now what is the meaning of value of k is equal to 0? So k is equal, I have mentioned basically try L means lower triangular, right?
Okay.
So basically this is a 0. So just try to draw this line, right? A triangular line. So below that it will try to keep the element, whatever element you have given, and above that it will try to give 0. This is what happens in lower triangle. Means in lower direction, so it will try to keep your exact data set, but in upper direction it will try to give you 0.
Okay.
Basically, in case of upper, just a reverse.
Okay, I got it. Thank you, Sudhanshu.
Yeah. Okay.
Sudhanshu, what is the practical application of this kind of?
Like I said, so unless and until you are not going for research, right? Like I said, so these are some of the functions, right? In NumPy, you will be not some of the functions. Like there are like more than 2,000 plus functions which is available. So unless and until you are not going for research, you are not trying to write some algorithm for some of the matrix manipulation, some encoder, decoder, or something like that. So you are not going to use this function at all. But this is something that we used to study in algebra. So in our 11th class or in our 12th class in our school days, so we used to study these things in our algebra. So that's the reason I have mentioned this function so that you will be aware about that. Like, okay, fine. So this kind of manipulation is possible. Maybe out of 1,000 people, 1 people are doing research, right? So they might be able to use these things. So that's the reason. Likewise, there are many functions you will be able to find out. If you'll see, if you'll check my slides, right? So like I have mentioned many functions. Most of the things I'm not going to talk about. I'm going to talk about only a generic one, the general one which we are going to use. But yeah, there are many functions which are available. So these are one of the functions for the matrix manipulation or array manipulation, I can say. A real-time application wise, without research, you will not be able to get all those things. Real-time application wise, suppose if I'm trying to write some algebra application, because I can say like image is nothing but some matrix, I can say. So if I just have to get the lower portion of the pixels, I don't want upper part of the pixels, right? In that case, yes, this is useful directly.
Yeah, thank you.
Right? So suppose if I'm trying to process a sound, and suppose if I have converted my speech, my sound into a spectrogram. So a spectrogram is nothing but a image, basically. So I'm trying to convert my speech into images, basically. So these are images, waves you will be able to see. Now, so if I'm just looking for lower portion of the wave, or after some threshold, I'm not looking for any of the waves or any of the pixels. In that case, yes, this is useful, right? So it is useful, but yeah, unless and until you're not writing your own algorithm, like it's just one of the function for you.
Sudhanshu, is the triu function
Yeah.
just the opposite of the trill function?
Yeah, trial basically. Trial means lower. Triu means upper. Basically.
So why? I mean, just out of curiosity, why you're using that -1 in both the cases? I mean, it's same. It's just reversing the.
No, I'm just giving you
the
I'm just giving example. You can use 2, 3, 4, 5, whatever you want. So minus means it will try to start from the negative axis, right? Positive means positive axis. So you can just use any function, meaning it's not going to change at all. K is equal to K value could be anything. You can pick.
Okay. And in the empty, function, the values which are coming, those are random values, right?
Those are random values. Yeah. For me, for you, it will be different value.
Okay. So what is the application of this? I mean, just to produce
I think
random
in a very first class, I think I was talking about something called as a weight, if you remember, right?
Yeah.
In the first unit of a class. Now, at that point of a time, did I said that weight should be random? And again, I said that. So whenever you're going to use like a neural network, right? So at the time of using,
so it's the back propagation that where it is required, right?
So basically,
the
whenever, so manually, if I'm trying to create my network, so can I say that I need a random weights? Means I need a random matrices. Weight is nothing but matrix I'm talking about, basically, right?
Okay.
So these functions will be useful. So rand function, rand in function, empty function. So these functions are useful, I would say. But yeah, like in those cases.
Okay, thank you.
Vatsal, you are not audible at all. Your voice is cracking a lot. No. I'm not able to hear you, Vatsal, at all. I think everyone is facing the same problem, right, everyone?
Yes.
Yeah. Your voice is cracking a lot. You can go ahead. I'll take one more question. Go ahead.
So row number 340.
Sorry, row number
340.
340. Where is 340? 340.
It's a
okay. 340. Yeah. What's an issue with this?
If I give one parenthesis.
Rajveer, you are not audible at all properly.
Is it
I think
okay
everyone
now?
is facing the.
Is it okay now?
Kind of, yeah.
Okay. I'm asking if I give.
No, again, I think you are trying to move away from the system. Whatever you are doing, don't do that. Focus over here. Come closer to the system.
Hello.
Yes, yeah, Rajveer.
Okay, I'm asking if I give the double parentheses or single parentheses, will it give me the same answer?
No, single bracket you're talking about?
Yeah, parentheses.
No, parenthesis and bracket. So my English is a bit bad actually. So like if you can explain me like
similar kind of, the similar kind of bracket, yeah.
Bracket, right? Okay, so bracket doesn't matter. Like you should give like at least 2 brackets because one is for function and like another one is for, I can say, this dimension that you're trying to give, right? It doesn't matter at all. It is not going to change your dimension. The dimension has been changed by numbers that you are going to mention over there.
Okay.
Yeah. Okay. Fine. Everyone. So Vatsal was asking question that which one to be used for the random number out of empty, random, or rand n. Vatsal, you can use anything actually. So depends upon your requirements. All those things used to generate a random number itself. Rand n, if I'll talk about, so basically rand n, I'll always try to give me a data set on a normal distribution, basically. So it depends. So whether you are looking for a normally distributed data set or you're just looking for like a just random data set with some integer or some fractions, I can say. So based on that, you can try to like take these things. Fine, guys, moving ahead. Okay, so here I'm going to talk about a few other functions. Okay, let me check how much I have to discuss today. Okay, so much. Okay, here, so I'm trying to use basically a function called as numpy.random.rand basically. So here it is going to generate like a data set with a uniform distribution. So whatever dimension I have given, so it is going to generate that dimension of the data set. Again, like I said, so like in the neural networks, so we have to give a weights, we have to randomly initialize our weights. So at that point of a time, you can use these functions. These functions is always like comes handy, and yeah, so frequently we use this kind of a functions, I would say, in this case. Now again, so I'm trying to use a rand n. So there is a difference between a rand and rand n. So whenever you're using a rand n function, so you will be able to use basically a functions on a normal distribution. Now what is the meaning of normal distribution or standard normal distribution? So you can attend my stats classes. You will get to know that, which is already there in your syllabus basically. So it is going to give you a data set with the standard normal distribution, I can say, where mu is equal to 0, standard deviation is equal to 1. So this is what you will be able to get in case of this one. Both are giving you like a random data itself, I would say. Now here I'm trying to call numpy.random.randint. So basically, like I'm trying to generate a data set. I'm trying to generate a random integer in between, I can say 1 to 10. So I'm trying to generate 100 data set in between, 100 random data set in between 1 to 10. So we have seen line space, basically line space was trying to generate a data. Here I have written basically a random, and here this is trying to generate 100 data set. So you will be able to see repetition, because integer wise, like in between 1 to 10, there will be only 10 integer. There could be only 10 integer, which is possible. Now here, so it is trying to generate hundreds, as simple as that. So again, randint. So here it is trying to generate a data set in between 1 to 100, and I'm looking for 4 cross 4. So I'm looking for 4 cross 4 matrices. So 16 data it is going to generate between 1 to 100. This is what randint does. Now, if I'll talk about this randint function over here, so again in between 1 to 7, so it is going to generate 20 data set. Someone is saying that you are not able to understand random functions. So Raghav, what you can do is, there is an option called as shift and tab. So just try to press that. Entire definition you will be able to get. Or else in your doubt session you can ask me. So there is something called as a reshaping. So reshaping functions we have already seen basically. So like from numpy, random, randint and all those things, so fine, I'm trying to generate a random number. So meaning of this things is nothing but I'm trying to generate a random number in between 1 to 100, and 30 such number I'm trying to generate. So fine, A is going to give you basically a 30 number A over here. So this is the 30 number it has generated. So random number it has generated for me. Yeah, as you can see, random integer it has generated for me, I can say. So here I'm trying to call a reshape of 2 cross 3 cross 5. So we have already seen so many reshapes, I can say, and -1 and all sort of stuff. So it's completely fine. So I'm not getting into this topic again for the reshaping. So fine, reshape is equal to 5 cross 5. We are able to do that. Okay. Now there is something called as a sorting. So let's try to understand this sorting kind of operation. So how sorting happens. So what are all things you can do with respect to sorting. Yeah. So here I'm trying to call basically m, and here I'm trying to call numpy.sort function. So basically I'm trying to provide my matrices. So this is my matrices which I'm trying to provide as of now in this place, as you can see. And for sorting, axis is equal to 0 I have given. 0 simply means it's a row. So axis is equal to 0 means row, axis is equal to 1 means column. It's a universal fact basically. Anywhere, wherever you are going to study these things, pandas, Python core or numpy. So axis 0 means I'm looking for like a row wise sorting operation, I can say. So axis is equal to 0 which I have given. So let's try to observe it. Again, it's a confusing. So just try to focus for next 30 seconds. You will be able to understand it. So it's literally confusing. Every time people just get confused. So here axis is equal to 0. I have said that axis is equal to 0 means ROW, row, basically. Now, if you will try to observe over here, you will tell me that, okay, fine, you said that it's trying to perform the sorting operation row wise. Now, where is row wise? It is trying to perform all the sorting operation column wise. But you are saying that, still you are saying that it's a row wise sorting operation. So actually, even now I'm saying that it's a row wise sorting operation. It seems like, it looks like that it's a column wise order which it is trying to generate, which it is trying to give it to me. But no, it's not a fact basically. So if you will check over here, 23, 20, so this is the original data set. This was the data set which I had. Now it has sorted this data set into this fashion. So basically what happens in this case is, so it tried to pull the data set, it tried to compare in this direction. So it is comparing in this direction. So basically row wise comparison it is trying to do. That's the reason. So it said that it's a row wise sorting operation that we are trying to perform. Axis is equal to 0. Now if you try to make axis is equal to 1, you will see that it's a row wise sorting, but no, it's a column wise actually. So here it will try to extract this data and then it will try to sort in this way. So like 23 will go over here, 25 will go in this place. I can say like 40 will come over here. So you can see that we are trying to shift rows from here to here. We are not shifting columns basically. So we are not playing around with columns over here. So we are not shifting columns over here. So we are shifting actually rows. So it looks like that it's a column wise sorting, but no, it's a row wise sorting operation. And axis is equal to 0 simply means it's a rows. So we are trying to shuffle basically. We are trying to move basically rows from here and there. So that's the reason it's called as a row wise. It's not a column wise, I can say. So this is what you will be able to perform in case of a row wise sorting operation. That is possible. Now, so if I have to find out a maximum from like matrices, I can do that as well. So I can call a matrices at matrix.max, and then it is going to give me what is the maximum element inside this matrices. That is possible. I will be able to get that. Now, so let's try to understand this one. There is something called as a max, and there is something called as a argmax. So let's try to understand the argmax. So argmax always try to give you a maximum element on a particular axis, I can say. So again, it's confusing, just like a sorting operation, I would say. So here I have like I have basically this matrices. I have written basically b dot argmax, axis is equal to 0. So it should give me basically a maximum element on every row, I can say. So let's try to interpret these things and let's try to understand. So basically argmax always try to return you the location of a maximum element. So now let's suppose this is like a matrix that we have. Now we have executed this argmax. Let me execute once again so that I'll get a correct output. Yeah, this is the correct output that we are able to secure. Now here you will be able to find out that this is the data. Basically I have written b.argmax axis is equal to 0. Axis is equal to 0 means row basically. So it should give me row indexes. Basically argmax always returns the row indexes of the maximum element. If I'm able to give axis is equal to 0, if I'm giving axis is equal to 1, so it is going to return me the maximum indexes of the maximum element column wise. So here basically you will be able to find out that in this one, so 0, 1, 2, 3, 4, 5. This is the index that we have. Now, so in a first one, so I will be able to find out that 90 is a highest element. Now index for 90 is equal to 2. We are able to get 2. In the second one, this one, 94 is the highest element. Index for 94 is equal to 0. So as you can see, it is returning me a row indexes. It is not returning me a column indexes basically. Now third one. So basically 90 is the maximum data. 90 is the maximum data set which you have inside this row. So 1. So 1 is the indexes. So 1 we are able to get. Now over here, so 54 is the maximum. Fine. For that I'm getting 2 as the indexes. Now over here 79 is a maximum. So yes, I'm able to get 2 over here. So this is something that you will be able to get. So argmax always returns the indexes of the maximum element, whereas max returns of data itself. This is what like you will be able to see. Now, so I'm trying to call like indexing and slicing. So it's the same kind of operation that we have already done. So here I'm trying to call numpy.arange. So numpy.arange is going to generate a data set in between like whatever range we have given. So fine, I have given 0 to 11. So it is going to generate data set in between 0 to 10. That is fine. Now here I'm trying to write array of 7. So array of 7 means what? So basically it will try to get a data from the 7th indexes, and indexes starts from 0. We know that actually. So whatever data we have on a 7th indexes, so yes, I'm able to get those data. That is not a problem. This is a slicing. So I'm trying to get a data from 3rd index till 6th indexes, excluding 6th indexes. So whatever operations we have done in our list, in our string, so similar kind of operations we are trying to perform even over there. There is no differences that you will be able to find out. Here I have given column 4 basically. I have not given any starting point. So by default it will try to consider a starting point is equal to 0. So it is trying to give you a data set from 0 till 4 excluding 4. As simple as that. So this is called as a slicing operation. So you will be able to slice a data in reverse direction, positive, negative, whatever you want. Now here I'm going to generate data, as you can see over here in this case. So this is basically a 2D matrices which I have created. Now, so I will be able to get any data set that I'm looking for. So if I'm looking for 57, so basically 57 is available on first row, I can say. So 0th row, technically. So 0th row and 0, 1, 2. So second column. So if I'm going to give mat of 0th row, and if I'm going to give a second column, yes, I will be able to get the data like a 57. So I think we all know that how to like extract a data, how to do a slicing operation in case of a matrices, in case of a multidimensional arrays. So that is like completely fine, I can say. Here, if I have written matrix 1 of 2, so it means that I'm trying to give a row index is equal to 1, column index is equal to 2. So this is one of the way to pass a row index and column index. This is another way to pass a row index and column indexes. Both ways are fine. You will be able to extract any data set. You will be able to do any slicing out of the NumPy matrices or NumPy arrays. It's very easy, I can say. Now here I have given certain range, so I have given row, I have given column. So suppose in some matrices I'm looking for a data starting from row 1 till 3rd and then column starting from 3 to 5. I'm giving those things over here, so it will be able to give me a data set in between that slicing. So if I'm looking for a subset of the matrices, I can get that. So from starting from row number starting from 1 to 3, column number starting from 3 to 5. So that slicing operation we have already done. So yeah, this is how it works basically. Fine. So here I'm going to talk about like again I've created a matrix, as you can see. Now here I have here I have mentioned matrix basically. So I'm trying to filter out the data. So matrix greater than 50. So if I'm going to execute these things, you will be able to find out this operation matrix greater than 50. So wherever data set is greater than 50, it is going to give you true. If I'm going to pass these things inside the matrix, I would say, so I will be able to get only those data set, I can say only those data set which is fulfilling this condition, or on that on whatever indexes we are able to get true. This is what happens. So this is just a basic filter operation that we are trying to perform in this particular case, nothing else. So these things you should know in a much better way. You should be well versed with all of those things because yeah, this things is very important as far as I can say data manipulation is concerned into NumPy. Fine. So here again I'm trying to create an array, as you can see, and I'm trying to call like a mat. I'm not given the starting point of rows, I'm not given the starting point of columns. So I'm just trying to say that okay fine, start from the row 0, go till 2, and start from the column 0, go till 2, give me the data set. This is the data set that you will be able to generate. So I'm trying to like extract just a subsection of the data set. Now, so arrays are a mutable element. Arrays are a mutable entity. So I think we talked about mutable entities in your Python classes basically. Like tuples are immutable element, lists are mutable element, strings are immutable elements, I can say. So in the similar way, arrays are mutable element. You will be able to replace any index value with some other values. So here what I'm trying to do is, so I'm trying to replace index 0 of 0. So if I'll talk about this index 0 of 0, when 0th row, 0th column values. Basically, I'm trying to replace these things with 1000. So yes, it's possible. I can do that. Basically, like arrays are mutable element. So yes, I will be able to do that. So fine. This is the same thing. I'm just doing a slicing operation. Okay. So before getting into this universal function, so universal and broadcasting is left. Fine. So I think we can take some questions now with respect to the slicing operation that we have discussed, subsetting we have discussed basically, and what? And we have discussed some max and argmax. So I am assuming that many people must be having confusion with max and argmax and all those things. So please go for your questions one by one.
Hey Sudhanshu, I'm actually finding a difficulty to find the actual, the Python notebook where these functions are actually existing. It's always like NumPy functions, all are actually the same name actually.
In your dashboard?
Yes, sir. Yes, sir.
Okay, so let's solve your problem then.
Session 4.8. Yeah, it's not clear which session is what. So actually finding a difficulty to find where the actual program is.
Yeah, and 4.4 is not there, Sudhanshu. I saw.
Sudhanshu, it is actually there if you go to file section, right? There is maybe in the top section 4.4 was there.
No, I'm just. Okay, so now you can go to your dashboard and you will be able to find a NumPy page that I'm talking about as of now, and exactly each and everything you will be able to find out in that one. And I'm just removing whatever material was available before.
Thank you, sir. Thank you.
So, yeah, I just
Sudhanshu, arrays are mutable elements. So can we
Yes.
say like NP array are Python list?
No, it's not like that. You can't say it that way. So NP array is a different entity, and other arrays are different entity. Yeah. Fine. So anyone who is having any questions, so I think let's get back to our
Hello,
discussion.
Sudhanshu.
Yeah.
Hello, Sudhanshu. Yeah. Whenever we are doing the sorting. Hello.
Okay. Yes. Yeah. Go ahead. I can hear you.
Yeah. Whenever you are doing the sorting, first if I do the sorting for axis equal to 0, okay, and next I will go for the axis equal to 1. Is it going to affect the axis 0?
No. Yeah. So it is going to affect axis 0 for sure.
So
if you're trying to perform this operation on a consecutively on the same matrices, right? So for sure it is going to affect. So final whatever you're going to do finally, so it is going to store that values.
Yeah. Is there any method so that we can perform without affecting the previous operation?
You can take a separate, I can say separate entities, and then you can sort it, because that's not possible, right? Practically, that is not possible to sort like a multi-dimensional data with with all the dimensions, right? Yeah. So you will be able to sort either in a one dimension or other, not in all the dimensions.
Okay, thank you.
Hi, Sudhanshu.
Yeah, go ahead, please.
What is the difference between normal random model and NP.random? Like we use import random.
I think random we have used with respect to NP itself. There is nothing called as a normal random. So there is something called as a rand that we have used, np.random.rand, and there is something called as a np.randn that we have used, right? So whenever you are using our np.rand, so in that case, what happens is if you will check the data set as I have shown you over here. So in that case, yeah, if I'm using rand over here, if I'm using rand n, that's the only difference that you will be able to find out. Both are the part of np.random, np.random. Now, in case of an np.rand, so you will be able to get the uniform distribution. Uniform distribution means so whenever it is, you will so get into a stats class. So if you will try to draw this data, so you will be able to get the normal distribution curve, but mu will not be equal to 0. and a standard deviation will not be equal to 1 in this case. But if I'm talking about this normal distribution data, so it is always trying to generate a standard normal distribution. So here, so whatever data it is going to generate, so yes, it is going to form a bell curve. Here mu will be equal to 0 and a standard deviation is equal to 1. So this, both of these things are generating a similar kind of a data set, I can say. The only difference between these two data sets is for one, so one is basically just a uniform distribution, means it is going to give you a bell shape kind of a curve if you try to plot a data set with the help of this bell shape. So like today itself, I was like in a 3 o'clock class, I was talking about this function. So f of x is nothing but 1 of rho root of 2 pi, I can say e to the power minus of x minus mu divided by rho of square 1 by 2 over here. So basically this is our normal distribution functions. I think it's, if it is not visible, so maybe I can try to rewrite. So f of x is equal to 1 by rho of root of 2 pi e to the power minus of 1 by 2 x minus mu divided by rho of a square. So this is called as a normal distribution function. So basically both follows a normal distribution function. There is no if and but with that. The only difference is, so basically, so whenever you are using rand n, so it is going to give you a data set where mu will be equal to 0. Mu is equal to 0 means average, or mean is equal to 0. And the standard deviation is equal to 0 means dispersion from the mean is equal to 1. This is what you will be able to get in this case, rand n. Whereas in case of only a rand function, you will not be able to get that data. But yeah, both are uniformly distributed.
Yeah.
Yeah.
Sudhanshu, Sudhanshu, you have used the from statement, right? Import and from. What is the meaning of that?
From
like, I mean, random is a class or?
Which one? No, random is a function. Basically, okay, this one is a package actually. So like NumPy package, inside that we have this
NumPy.
one package, and then we have this function inside that one. Okay.
Okay. Random is a package, right? Then
you can say that in that way. Random is a package, or you can say class dot this one, package dot class dot this one. You can say this way. NumPy package, random is a class, then random is a function. So you can define it even in
okay.
that.
Okay.
Okay.
Thanks.
Yeah.
So I think only random is there. Someone has asked the question. Just random. Only random is also there.
Yeah, only random is also there. So that's also generating a uniform function, uniform like a distribution. So all those data set which is generated by a random, and its rand function. So all those things used to give you a uniform distribution data set itself, I would say. Right now, what is the meaning of like a normal distribution? So yes, whenever in your class I'm going to talk about statistics, so I think you will be able to understand those things. You will be able to visualize those things mathematically. But yeah, as of now, I can say that it forms a bell curve.
So what I have seen actually is that random is they are using in game development, something like that.
No, it's not in a game development or something like that. It's fine just to generate a random data set. So use could be
random number generator.
Yeah. So any other questions we have?
Hi, Sudhanshu, Rajveer.
Yeah, go ahead.
Sudhanshu, my question is there regarding the sort function, np.
Okay, sort function, fine.
So we've seen that merge soft is a parameter. So
yeah, merge sort is there. So likewise, there are other 3 algorithms which you will be able to find out. So actually, if you have like studied these things in your college life, so basically, like in college life, so we used to talk about like a different kind of sorting algorithm, right? Selection sort, merge sort, bubble sort, heap sort, like a merge sort, quick sort, I can say radix sort, right?
Okay.
So we used to talk about all those algorithms. So here you will be able to find these algorithms. So you'll be able to pick any of these algorithms. It doesn't matter over here as of now on this level. But yeah, data structure wise, all this sorting algorithm is different. Complexity of this sorting algorithm is different, I would say.
Okay, so does it impact the model?
Unless and until you're not having a very huge data set, it's not going to impact. You're just performing a sorting operation. So basically, sorting is a linear operation. So complexity of this one will be equal to n, as simple as that.
And one more question, a bit.
If you're using merge sort, then it will be n log n. Yeah.
Okay, so one more question, a bit from this, not from this class.
Okay.
From the pandas library.
I think we should focus here. So in pandas class, so I think I'll talk about that. Don't worry.
Okay.
Yeah. We have a class in weekdays, right? Yeah.
Sudhanshu, do you recommend, for this class and for this, exercise, do you recommend to, know data structures on a full? Or,
no, not at all. You should not know even a single data structure. Okay. That's not required.
Okay, normal sort will, and a normal understanding of merge sort, quick sort will do the trick.
Not at all. You're not supposed to even know that one. It's completely fine. If you've heard about name, that is completely fine, right? So it's completely fine as a data scientist. You're not supposed to know that. Okay, I know all those things because I used to teach those things. I used to get into data science. I belong from computer science background and all those things. So maybe because of that, right? But it's not mandatory for a data scientist, I would say. Yeah. Okay. Fine. Questions, please.
Can you just, explain once?
Avironi, Avironin. So your voice is not audible.
Sudhanshu, will you start TensorFlow today?
I'm not thinking of doing that because I don't think I'll be having the time. So I have to discuss tab of this chapter.
Okay.
Yeah.
Okay.
Yeah. Any question do we have?
Yeah. Can you check chat actually? I just pinged you one question.
Sort array in reverse order using the sort methods. Okay. So you are saying that can we sort this array?
No, not that one. That's not mine.
Is add the human activity. This one, human activity?
No. np.arrange 2,22. Can you just paste that code actually?
Which one?
My name is Pankaj.
Okay, Pankaj Dhapola.
Yes, that's good. Yeah.
Can you please type this code? Which code? After that, I'm not able to see any code.
Achha, I'm pinged again.
Okay. Now, what's the problem with this code? So yeah, tell me.
Yeah. There's a loss of data.
There is a loss of data.
Can you see that 13.9999599 this one?
I think you are able to get all the data set. 21.6.
No. See, I can you go
21.6. Yes, you are able to get that, right?
Can you go up actually a little bit?
Yeah.
At the code. Yeah, look at the code.
Yeah.
There's this. I am printing an array ARR.
Okay, fine.
And when I use a loop over there,
okay,
then there's a loss of data actually. You can see.
Where loss of data? So means in terms of counting, you're saying that you're not able to get the same count.
So he is actually saying instead of 19.60, he's getting 19.599999 like that.
Yes.
Okay, this is what you're saying, right? So like
yes.
21/6. That is fine. So basically, it's used to show you the absolute value. It's just a representation. It's fine. The meaning of 49.99, if you try to convert these things, if you try to write off, it will be like a 21.6 itself. There is nothing loss of data.
Yeah, Sudhanshu, is it possible to reverse sort is possible? As I mean to say ascending or descending, changing the sorting kind. Yes.
Got it?
Yeah. Got it. Thank you.
Yeah. Okay. Okay, fine, everyone. Moving ahead with the next topic. Subsetting is fine. We have done that. Slicing, we have done that. Universal function. Okay. So fine. Yeah. Let's talk about this. So we have basically matrix 1 and matrix 2. Two matrices we have created. So this is one matrix. This is the another matrices that we have. So that is completely fine. We have two matrices in this place. Now, so we are trying to perform this operation. So matrix addition operation we are trying to perform. So whenever we are going to perform this matrix addition operation, so please be on mute. Those who are not speaking, and please don't try to speak at all. Yeah. Thank you. So basically matrix 1 and matrix 2, if I'm trying to say over here, so basically like it will try to perform this matrix addition operation element wise. So it will try to add this with this, it will try to add this with this. So index wise addition operation it is going to perform, and finally you will be able to get the data set accordingly. So this is what happens in case of a matrix addition operation. Now if I'm talking about matrix multiplication operation, so if I'm using matrix multiplication is different and cross symbol is different. So if I'm trying to show, yes, basically, if I'm trying to use basically this static sign, so this is not a matrix multiplication operation. This is basically index-wise multiplication. Index-wise multiplication is different and matrix multiplication is different. So I'll show you. So what is the difference between index-wise and like a matrix multiplication? So basically, like if I'm talking about, so I think my white page is visible to everyone. This is what I'm assuming. So suppose if we have a matrix, so 2, 3, 4, 5, this is one matrix, and suppose if I have another matrix basically, so 1, 3, 4, 5, something like that, let's suppose. So I have basically a matrix 1, I have basically a matrix 2. So I have basically these two matrices. Now if I'm going to do matrix 1 into matrix 2, so what will happen in this case? So it is going to perform index wise operations. So 2 cross 1. So 2 cross 1 it is going to perform, I can say. So 2 cross 1 it is going to perform. So 2 cross 1 is equal to 2. Now 3 cross 3 is equal to 9. 4 cross 4 is equal to 16. 5 cross 5 is equal to 25. So this is that output that you will be able to get of the matrix 1 into matrix 2. But this is not a matrix multiplication. This is called as a index wise multiplication. Matrix multiplication is something different. So suppose if I'm talking about a matrix multiplication, so basically what happens in case of matrix multiplication, you will multiply this with this, you will multiply this with this one. So let me show you what is the matrix multiplication output you will be able to get. So basically matrix multiplication wise, so 2 cross 1, so 2 cross 1 plus 3 cross 4. Now 2 cross 3, 2 cross 3 plus 3 cross 5. Now 4 cross 1 plus 5 cross 4. Now 4 cross 3 plus 5 cross 5. So if you try to find out this solution, so that will be a matrix multiplication. So like 2, then 4, 14, 9, 3, 6, 5, 15, 6, 6, 4, 5, 20, 4, 24, 4, 12, 25, so 37. Okay. So this is what you will be able to get as a result of matrix multiplication. This is what you will be able to get basically with the help of index wise multiplication. So this is the difference, I can say. So the matrix multiplication is this one. This is how it happens basically, and this is the just a index wise multiplication. So whenever you are going to use static symbol, so this is called as a index wise multiplication. Now if you are going to use @ symbol, so in that case it is called as a matrix multiplication. So always remember that. Now moving back. So again, okay. So here basically what I'm trying to do is, so I'm trying to use basically a mat 1 into mat 2. So basically if I'm using mat 1 into mat 2, so this is not a matrix multiplication at all. So don't get confused that I'm talking about a matrix multiplication. This is just an index wise. So it will multiply it, give it to you as a value. You can verify that basically like a 8 into 9. So 9 8 ja 72. So you will be able to get that. Now this is the division operation. So again, this is like the index wise division operation you will be able to get. So you will be able to do any kind of a mathematical operation. There won't be any issue at all. Now I'm trying to do 100 plus matrix 1. So it will try to add 100 with every element, I can say. Now here it is going to give you the power. So it is trying to, again it is a index like a element wise operation. So it is going to cube. It is, so because double static means it's a power. So matrix 1 to the power 3. So basically it is going to cube each and every element, whatever element is available inside the matrices for every element. Again, there is a function called as pow. So pow function, it takes a matrix and as well as it is going to take the power. So it is going to take matrix, whatever power you wanted to give, you can give it. So I'm giving power of 1 by 2, means I wanted to find out the root of every data set, and that is fine. I will be able to get that. Now there is something called the broadcasting. So let's try to understand this broadcasting. So here I'm trying to create a matrix of a zeros matrix of 3 cross 3, I can say. So fine, I will be able to get that 3 cross 3 matrices. I will be able to broadcast that thing. Now, so after doing that, so I'm able to broadcast this thing. So after doing that, I will be able to get this matrix 3 cross 3 matrices. Now what I will do is, so I'm trying to call numpy.array, and in numpy.array, so I'm trying to basically give this 3 data set 1, 0, and 2. Now, so broadcasting simply means trying to perform a similar kind of operation with row wise or column wise. Now let's see what happens. So here I have a 0 matrices. Here is like a data that I've created, array that I've created. Now if I'm trying to add this one plus this one, if I'm trying to add it, basically start plus adds 1. So this one will go to every row and then it will try to perform this operation. So 1 will add with this one, 0 with this one, 0 with this one, 1 with this one, 0 with this one, 0 with this, 2 with this one. So you will be able to get 102, 102, 102. So basically it's a broadcast. I have broadcasted a data, I can say row wise. So I will be able to broadcast data even column wise if I'm able to generate that kind of a data. So to generate that kind of a data, what I'm trying to do is, so I'm trying to create an array basically, and I'm trying to call a transpose. Transpose means just rotate basically. And so I'm trying to take this array and then I'm trying to rotate it. So whatever there was available as a column wise, so now it will be available as a row wise. So to transpose any data set, like a simple function is dot t. So capital T, not a small t. So if I'm going to create this column-wise data, so I'm trying to broadcast it column-wise. So column-wise, I'm trying to perform this operation, as you can see. So that is completely fine. I'm able to do that. So now it will work. What has happened? Okay, I have given one more element. Fine. Okay, now if you are going to use just a vector, like just a scalar, so just a one single entity if you are going to take, so in that case, like you can use like 100, so it is going to add these things with all the elements. So this is what happens in case of this kind of broadcasting. So this is all about broadcasting. Now, so like this is matrix 1 and matrix 2 I was trying to generate. So we have a matrix 1, we have a matrix 2, so it's completely fine. I have these two matrices. Now if I wanted to find out the square root of all the matrix element, so yes, it is there. You're just supposed to call a square, or what you can do is you can write into this way. So POW, both are the same, I can say. So you can provide a mat1 comma and then power is equal to 0.5. So power is equal to 0.5 means 1 by 2. 1 by 2 is nothing but the square root I'm trying to find out. So both is going to give you the same data set, as you can see, basically. So in either way, you will be able to perform this operation. Exponent, so it will try to find the exponential of every elements. So again, say element-wise operation, logarithmic. So if you are looking for log of something, so it will be able to find out. So end of this NumPy section. So likewise, there are many more functions which is available in NumPy. Almost all the mathematical functions you will be able to get inside a NumPy. That's almost endless, I can say. Number of functions that you will be able to get inside a NumPy. If you will start scrolling down this NumPy, so you will be able to see that how many functions are available and function inside the functions are available. So you're not supposed to know all those functions, whatever things we have discussed so far, you should know about all those things. And yeah, for sure, in a later stage, you will be able to explore each and everything if you know all those basic things. Manipulation, matrix manipulation and array manipulation. So now, if anyone is having any concern, please go for question. After that, so we'll go for the TensorFlow installation, because from tomorrow we are starting TensorFlow, which is required for the deep learning. So we'll do this installation today itself in most of your system, and then we'll take it ahead. So yes, everyone, if you have any question, go for it.
Sudhanshu, can you explain matrix multiplication?
Which one?
Matrix multiplication using at.
Using?
At. You said like you gave an example, right?
So basically, yeah, at the rate if you're using, right? So in that case, you will be able to get this data. So this is basically a actual matrix multiplication with the help of at the rate. If I'm giving a static over here, so in that case, it's not a matrix multiplication, it's an index-wise multiplication.
Can we call that as a dot multiplication? Dot operation?
You can say that. Yes, you can. Yeah.
Okay. One more doubt. What is the applicational use of broadcasting?
So broadcasting means if I have to perform a similar operation with all the rows and all the columns, right? So I can use a broadcasting. So that is a use of broadcasting, I can say. So at the same point of a time, so I'll just create a one array. It will broadcast across other arrays.
Okay. Thank you.
Yeah, actually, I'm in broadcasting. I'm having a matrix of 3 by 3 and another matrix of 2 by 2. I want to perform addition of those matrix, but how it is going to broadcast that?
Sorry, what was your question?
I'm having matrix A, which is of shape 3 by 3, and matrix B, which is of shape 2 by 2. Okay. Then how it is going to broadcast?
So in that case, it is not going to broadcast. So for broadcasting, so shape should be same. Yeah.
At least one dimension should be same. You mean to say?
Dimension should be same in which you are broadcasting. So I'll show you these things over here. So basically, if I'm trying to change this dimension, right? Let's suppose this is the dimension is equal to 1 row, 4 column, right? Now in my data set, so I just have 3 columns, right? So if I'm going to broadcast this with this, it is going to give me issue saying that operation could not be broadcast together with the 3x3 or 4. Making sense?
Yeah.
Hey, Sudhanshu. Yeah. Okay. Yeah, we are doing transpose, right? Where we are, in transpose, right? Where you are giving an example. Okay. There, right? You are changing rows into columns now. Or,
yes.
Okay.
Yeah.
Okay. But you're using the same thing. Does this affect? Usually in copy, right? You showed that if you don't use copy, there is a chance of affecting the elements inside, right? Now, how does this remain same?
No, transpose means just a rotation. You can't correlate with the copies basically. So basically, I'm trying to rotate my data set by 180 degrees. This is called as a transposing of the data. So I'm just trying to rotate the data. That's it. Nothing else.
Okay. Modifying the end. Okay.
Not at all. No, not at all.
Hi Sudhanshu, because here, when are you going to have our pandas class?
In your Python classes, basically. So you can check the sequence. So I think we have discussed OOPS programming. After that, exception handling. After that, pandas.
Okay, fine.
Yeah. Okay, everyone. So if anyone is having any questions, you can ask. I'll take 2-3 more questions on this one, and then I'll go ahead with the installation.
Hello, sir. Like with the given knowledge for all these 2 weeks, are we ready for the TensorFlow and all those things?
All we ready for?
The TensorFlow.
Don't worry. Join tomorrow's class. You will be able to understand. I'll make sure. Are you able to understand whatever we have discussed so far?
Yes, sir.
Then you will be able to understand all those things in every class. Yeah, go ahead.
Are you going to tell the installation of PyCharm today, or
sorry?
Are you going to tell the installation of PyCharm today?
No, not installation of PyCharm. Tomorrow we have a TensorFlow, right? So I don't do multiple things at a time.
Okay.
One thing at a time.
Yeah.
How many topics we completed in the deep learning?
Check your class basically. If you are not, why you are
Actually,
asking all those
join the
unnecessary
class.
questions? Yeah, so you should join on a time, right?
That's fine.
It's your responsibility to find out. Not everyone.
Anshu, Deepak this side.
Yeah, go ahead.
Yeah, Sudhanshu, will we only cover TensorFlow for the deep learning part or PyTorch as well?
No, PyTorch as well. I think I have repeated more than 15-20 times.
Okay, because TensorFlow is way too complicated.
Who told you?
I mean, I tried it and
is it?
The way it works into.
Fine. We'll see all those things. I don't think that you have even tried.
Yeah, Sudhanshu.
Anyone who is having, first of all, anyone who is having question with the NumPy that we have discussed? Anyone? Any single person in this group?
No.
Yes? Okay. No. Then do one thing.
Yeah, Sudhanshu, I have one question.
Yeah.
Whether we are going to cover the pure TensorFlow APIs or it is a wrapper APIs of Keras?
Let's see that. I don't think that this unnecessary question you should ask. Basically, when I said that from tomorrow I'm going to talk about TensorFlow, we'll talk about TensorFlow. Simple, right?
Yeah.
So I'll talk about those things.
One quick one. So, when we'll use the inverse matrix and rank of matrix in our deep learning classes?
Ranking in general, you are not supposed to use rank matrices. In general, no, that never happens actually. Unless and until mathematical function you're trying to develop by yourself, right? Because ranking is like having its own different meaning. I can say try to find out all the distinct rows and different columns after decomposition. That is called as a ranking. So ranking has been used basically inside of PCAs, I would say, or kernel decomposition when we talk about. So at that point of time, ranking we can accommodate in machine learning. In deep learning, I never seen that.
Okay. And the det also we are not going to use. Determinant.
No, determinant also we are not going to use. But yeah, determinant simply means like it is going to give you multiplication of rows cross columns and then like final values of the one matrices. So it's again a decomposition. So no, we are not going to use.
So there is no point of using inverse also, right? We may not using
not inverse transpose max to max you are going to use for sure, right? But in machine learning, yeah, like there are lots of functions which we generally use with respect to this one. Fine, everyone. So anyone?
Yes, I have one question.
Yeah.
Actually, in what scenarios the matrix multiplication is applicable in real-time scenarios?
See, people used to ask, okay, why we used to do 1 plus 2? Yeah, tell me why we used to do 1 plus 2. So people try to ask, okay, fine. So what is the real-time scenario of this 1 plus? What is the real-time scenario of 1 plus 2? So we use for addition, right?
Yeah.
When used for addition, right? So wherever you have to do addition, you have to do addition. As simple as that. So whenever I'm looking for a matrix multiplication kind of a result, so like it should like try to multiply a pixels, and in terms of matrix multiplication, give me, I'll use that one. That's the use of mathematics, I would say. So everything can't be in terms of like a real time, right? I can't be correlated. Just for blabbering, I can say that, okay, fine, everything we are going to use into like a deep learning or image processing or like a pixels and all those things. But that is not a fact, right? Okay. These are the mathematics, right? So like for data manipulation, anywhere, wherever it's recorded, we are going to use it. Okay.
So one last question regarding assignments. Actually, when we are going to get the next assignment?
You will get it soon. So I'm just waiting for a few topics to wrap up. So you will get it soon. Many assignments you will get it in a single shot.
How to submit assignment through GitHub?
Check your class number 1 videos. Yeah.
So I have one question. Like when we are planning for that in a EDA session.
EDA? EDA will happen in Python, not here.
Oh, okay. That will be happening on this coming week, or just wanted.
Just check your sequence in a dashboard. I think you will get it. Yeah.
Sudhanshu, can you start the installation process?
Yeah, otherwise people will keep on asking.
Yeah, they are keep on asking the same questions.
Exactly, yeah. The same question people ask in a doubling session. Yeah, like they're dumb or something. Okay, so anyone who can share their screen. So basically, like in my system, I have already like installed this TensorFlow. So I'll tell you the instruction. Even if you're facing any issues, so I'll just try to handle it from my end. So fine. Who has shared the screen? Kanan, right?
TensorFlow required a computer specification.
So do it in your system, you will get to know. Okay, Kanan, so just try to do one thing. So go to your Anaconda prompt and everyone try to follow the same thing. So open up your system and whatever we are doing as of now, do it. Because from tomorrow on, Anaconda prompt, not navigator. Yeah, fine. Now, so just try to do one thing. So try to write Conda, CONDA. Everyone do the same thing. Conda, CONDA space. What is this? Conda space create -n space -n. Yeah, space TF. So space Python is equal to 3.6.8. So basically what we are trying to do is, so like generally you are using your base environment as of now. Just try to understand this one, why we are doing this thing. So I'm trying to create basically a virtual environment over here. Virtual environment means, so you will be having, you can have a multiple version of Python in a single system itself. You're not supposed to set up a multiple environment by uninstalling or installing. You can keep hundreds, 200 or thousands of environment basically in a single place. Now, so here I have written conda create. So conda create will try to create a new environment. Here I have created -n. -n means nothing but it's a name that I'm trying to give. So I have given name as TF. As of now, if you will try to launch your Anaconda, so you must be able to see a base in a very beginning of your Anaconda prompt itself. So it's a base environment. Likewise, I'm trying to get another environment inside your system, and -n so is equal to TF that I have given. So TF could be anything. You can give your name, you can give my name. So TF is not a keyword as of now. So you can give any name over here. That will work fine. I'm trying to install these things with the Python 2008. Hit enter. So everyone do the same thing. Conda create -n TF Python is equal to 3.6.8. I'm going to ping you a command in your chat box. You will be able to see that. CONDA create -n TF Python is equal to 6.8. Okay. Yes. So just command I have pinged you in your chat box. Just try to copy it and paste it in your terminal. Kanan, right? So just try to say press yes over here. Why? Why? Yes, enter. Just wait for some time. It will take time. You will install all those libraries, all the dependency. Then I'll tell you next step. So first of all, try to create this environment. Keep these things ready. It depends upon your internet speed, internet connectivity, basically. So it is going to take some time.
So for me, it is not working.
Which one is not working?
I'm doing in Anaconda prompt. It is showing me conda is not recognized as an internal or external command. Operable.
Where you are trying to do?
In Anaconda prompt.
Is it? So share me your screen.
Yeah, just a moment. I cannot share.
Okay, let me activate multiple participants. Okay, now you can share.
Okay. Can you see? Can you see?
Yeah, I can see that. Basically, so which version of Conda you have installed and which system you are using?
In Windows 8 and Anaconda 3 I've installed.
Windows 8 you are using. Just try to search Anaconda ANA.
Yes,
close this one.
Actually,
try to click on Anaconda prompt.
Yeah, you can see. So first one I'm selecting.
Yeah, first one selected. People who are not doing anything right, so please be on mute immediately. I'll remove you without giving you next warning. Okay, let's remove few people. I think that will be much better. Fine, done. Yeah, so just show me like your Anaconda prompt.
Yeah, this one.
This one, right?
Yeah.
Okay, this is your don't recognize as
I
an
don't know.
internal command. I don't like why you are getting this kind of screen because it should not give that. Okay, remote control. Give me remote control. Okay, fine. I think I have access.
Install.
Install.
Okay, that's not
For me,